Is the Black Hole Lab, and the goal of the lab was to observe the motion of a star orbiting a black hole and using Newton's second law to determine the mass of the black hole. And the mass was found to be 1.99 times 10 to the 31st. The star was chosen to be the system with a mass of 1.98 times 10 to the 30. Delta T is 1 Earth day, which is equivalent to 86,400 seconds, and the black hole's initial position was at the origin. The star's motion was given in a CSV file and uploaded into Python. The initial conditions were added into the Python file, and the data was imported right here in this line. Okay, and in the first while loop right here, it calculated each of the velocities separately, because right here it shows that the change in position over the change in time is an approximately good representation of dr dt for a small delta t. And in the second while loop, the initial and final momentum and velocities were calculated and used to find delta v and delta p. And the motion is described by the change in momentum over the change in time, or dp dt, right here. And right here. And we also know that F net is equal to dp dt because of Newton's second law. And the motion and the net force was broken down into parallel and perpendicular components. dp dt and F net alike are composed of the sums of the parallel and perpendicular components. And the parallel components show the motion speeding up or slowing down, and the perpendicular component shows the curving of the object. And finally, the F net equation right here was used right here in the code to solve for the unknown, which would be the mass of the black hole. And this is what the code looks like when it's run. And the black arrow shows the parallel force, and the blue arrow shows the perpendicular force, because it always points towards the center of the kissing circle, and the yellow arrow shows the net force of the star. And as you can see, the final position, F net, dp dt, parallel, perpendicular, and the mass of the black hole is all printed out. F net perpendicular, F net parallel with dp dt parallel, and dp dt perpendicular. And as you can see from the equations printed out from the print statement, the values are the same. However, conceptually there is a difference, because F net is the force causing dp dt to change. Placed in the same location and the star's motion remained unchanged, is it possible to find that the new black hole has a different mass? And it's not possible, because it must be the same mass, because no other variables are changing in this F net equation.